All right, so just a few reminders about what is due and what we have going on in the next week. So exam reviews Sunday night and Monday night. They're posted up here. In addition, on Monday night from 7 to 9, the TAs will be doing just question answer review sessions. It's in Wilson. I don't remember the room number, but you should read through the exam announcement posted on D2L, which gives all that information. Monday's class time will be an optional review. So what that means is we're not taking attendance on Monday in class, so we won't have any exploration points due. But I will be here and I will be reviewing for the exam with anybody that chooses to come. So that's up to you whether or not you want to come on Monday the 11th. You do have a quiz due that night. It is up and available. Quiz 2 is all graded by D2L. So once you turn in quiz 2, that will be the grade that you have. The answers will be available after 11:30 that night. So you should be able to check your correct and incorrect responses. Our exam is Tuesday night, February 12th from 6:10 to 8 in Barnard 103. That's where my 3 sections are, is in Barnard 103. If you have a university-related absence or a blue card, you need to follow the instructions in the exam announcement by tomorrow in order to set up exam accommodations. And then I also want to just point out that Wednesday you have a RAT due. That is because we have new material covered the day after the exam. That RAT I will post this afternoon, so you can do it at any point between now and next Wednesday. But this is one that people tend to forget because it's right after the exam. So I just suggest just doing it and getting it out of the way. Like I said, it's not there yet, but I'll get it done this afternoon. I wanted to take a minute to show you where there are a couple exam review stuff. On D2L, if you go to content, under unit 1, there is review material. So if you go down to the kind of the bottom of unit 1, it says review material. Within that review material is that golden ticket. That's that full sheet I gave you guys. But in addition to that, the practice exam is there. This is the exam that will be used in the review sessions. The key to this will be posted Sunday night. Things to know for exam 1 is just a PDF document that kind of goes through each chapter that we've covered and just general information on things you should know for exam 1. Then these last 2. So this review table ISI exam 1 is a blank sheet that has, from that golden ticket, what we have covered so far in this semester. The reason I post this is just if you want to use this as part of your cheat sheet, you may. You are allowed 1 sheet of paper front and back, just a regular sheet of paper like this, 8.5 by 11. You can print this out, hand write in the answers, and then use the rest of the space for the rest of your cheat sheets. You don't have to use this, it's just there for your use if you want. So then you can use, I posted the key to that part of the exam, or of that review. You may not print this and use this as your cheat sheet. You can use this to fill in the blank one, but it all has to be handwritten, okay? So you can print that blank one and then use this to help you fill in that sheet and then put whatever else you want on that sheet. Any questions? Yes?
Do you need like a more expensive calculator?
You need a calculator. It does not matter. As long as the calculator can't access the internet, you can use it. Okay, so you don't need like a graphing calculator. Just a plain Jane calculator will work fine. You have to take the square root because we have calculations where we take the square root. I highly recommend that you make sure you know how to use the calculator that you bring to the exam. I have had people before that come to the exam and they ask me for help on using their calculator, and I can't do that right at exam time. If you find that you don't know how to use your calculator the day or so ahead of time, I'm happy to meet with you to try and help you figure it out. But just make sure you're always using a calculator that you know how to use. You will need a calculator. I do require that you take the exam in pencil. Just makes my life a lot better, a lot easier to grade if you erase answers that you thought are incorrect and write the new answer rather than scratching out and trying to write something else. Any other questions?
Do our notes for that cheat sheet have to be in pencil?
No, just not typed. Any other questions? Okay. All right, so that's just a little bit of information about that exam. Is everybody here? CJ, Brian? Kinsey, will you do it today then? Okay. Josie's here. Quinn? Okay. Parker? I don't know anybody's names yet very well. Is Parker here? He's not here? Do you want to do it? No? I'm going to put you on the spot. Kathleen, will you do it today? Be the spokesperson? Okay. All right, so we're going to start with reviewing question 8 from Exploration 1.5. So this is on page, we're around like page 68 was the start of the exploration. So obviously I have all 3 of my sections up here. So our section is section 16, so that's that last standard deviation, or standard deviation calculation there. So square root of 0.5 times 1 minus 0.5 divided by 108. So you should have gotten a value of about 0.048. Is that what you guys saw for question 8? All right, so first question I want you guys to discuss at your tables is why we would see that section 10 had a larger standard deviation than our class section. Quinn, why did your guys' table decide that our standard deviation is smaller than section 10's? Okay, good. So in section 10, they only have a sample size of 47, and section 16 had a sample size of 108. Section 10 is actually my largest section. Odd, I know. But what do you think we did in that class?
Did you not combine with the
Class data. We did not combine with the class data because we had enough successes and enough failures within that class to be able to analyze the data as is. But we ended up with a smaller sample size because remember in here our validity conditions weren't met, so we added in the author's class data, the 54 out of 83. So this is a point right here to see that if smaller sample sizes will end up with larger standard deviations. You should know how to interpret this standard deviation, the standard deviation of p hat. Remember that when we have the parentheses for p hat, it's just telling me what standard deviation I'm looking at. I don't need to put a value in there or do any multiplication. It's just saying, now I'm looking at the standard deviation of sample proportions. So when we talk about the interpretation of a standard deviation, we're just talking about how far each value is on average from the mean. So for this standard deviation, I could say the simulated sample proportion of students who call heads for the outcome of the coin toss vary from the mean of the null distribution of 0.5 by, now I can use our sample standard deviation, 0.048 on average, okay? We're looking at the variation of those sample proportions. Questions on question 8? Okay. Question 9 was calculation of the standardized statistic. So you used our sample statistic of 0.648, so that was our class plus the author's class, minus the null value of 0.5 divided by that standard deviation that we looked at in question 8. All right, discuss at your table for which section the standardized statistic provides the most evidence against the null, and why. All right, CJ, what did your table decide?
Said section 7, because it has the largest largest value.
Okay, the largest standardized statistic. Okay, yes, section 7 would have the statistic that provides the most evidence against the null because the value of their standardized statistic is the largest. The larger the standardized statistic, the farther away our statistic is from the null, the more evidence we have against the null. Also, making sure we know how to interpret this value. On assignment 3, I saw a lot of people not interpreting the standardized statistic as we asked you to, but evaluating it, talking about how much evidence that standardized statistic provided against the null. An evaluation would talk about how much evidence we have. Do we have strong evidence that whatever our null hypothesis is against our null? An interpretation is explaining what that value means. The observed proportion of students who called out heads in class and the author's class of, using our statistic, 0.648 is 3.08 standard deviations above the null value of 0.5. Why am I saying above the null value of 0.5 and not just away? Right, so if we just said away, we're not saying if it's above or below. If it was a negative value, then we would say it's below. It's this number of standard deviations below. On D2L under notes, I have a document that's called Evaluations and Interpretations. It's based off of Exploration 1.2. One of our instructors took the time to go through and write some good evaluations and bad evaluations, good interpretations, bad interpretations. I would highly recommend you look at that to make sure that you are including everything you need to when you talk about an interpretation. Either a p-value interpretation, what does the p-value mean, or the standardized statistic interpretation.
Where's that at?
Content Unit 1 notes. Okay, other questions on question 9 or 10 or 11? All right, so we are going to move on with this exploration today. Yes.
I actually do have a quick question.
Yes.
When it asks about the difference between the theory-based standardized
In question 11.
yeah, 10 and 11, they both sort of ask about that.
Okay, they should have been pretty similar. Okay,
Is one going to be higher than the other on average, or are they going to be about the same?
they should be about the same if our validity conditions are met. Okay, and we're going to talk about that in questions 13 through 15 a little bit. So 10 and 11, your p-values should have been approximately the same for the normal approximation and the simulation. The standard deviation, the standardized statistic, and the p-value for the theory-based should have been about the same as what we saw in the simulation as well, because our validity conditions were met, because we had at least 10 successes and 10 failures. In a few minutes, after we look at a couple things here, we'll look at questions 13 through 15 and see how those are not the same values when those validity conditions are not met. Any other questions? Okay. So when we have categorical data and our validity conditions are met, we have at least 10 successes and 10 failures in our sample, we can approximate the distribution with the normal approximation. This is because of that central limit theorem. The central limit theorem, as we talked last class, tells us then that our mean would be pi, the null hypothesized value, and the standard deviation would be the square root of pi times 1 minus pi over n, the sample size. When we use that normal approximation, this empirical rule also holds. The empirical rule, which was covered in the normal probability supplement on D2L, tells us that 68% of the values of x will fall within 1 standard deviation of the mean. 95% of x values will fall within plus or minus 2 standard deviations. And 99.7% of the values will fall within 3 standard deviations of the mean. We're going to use this empirical rule throughout the rest of today's activity. I am going to move on, but I'll come back to this slide in just a few minutes. So if you're writing this down, you can continue to write this down. Question 12 in the book, we're going to use just the author's class data, which is p hat equals 54 over 83. I do want you to do question 12 and then work through the supplement using just the author's class data. And as you read through question 12, it tells you to use a null hypothesized value of 0.7 because we're now assuming that people will choose heads 70% of the time. So we're going to test a null value of 0.7. I do want you to take the time to calculate the standard deviation of p hat using the equation and the standardized statistic using the equation. You will have to simulate the null as well and double check your p-values. You'll have to check normal approximation to get the p-value for this appropriate test. But I do want you to take the time to do the calculations. All right, so we're doing questions 12 and the supplement. We're going to talk through some of those in a few minutes, and then we're going to move on to exploration 3.2. All right, we're going to take a few minutes to talk about a couple things here. You might not have completely finished. That's okay, because I'm going to go through each one of these. We are looking at our simulation up here. So things to kind of point out here is the simulation is giving the same information as our theory-based tests. So up here you can see based off of our simulation, when we put in the value of 0.65 and we're testing a two-sided test because we're trying to see is it different than the 70% probability of choosing heads, we see a p-value of 0.332, okay? So that's the probability of our sample statistic or more extreme if they're choosing heads with a probability of 70%. We can also use theory-based methods. So we can find that standard deviation of p hat, which is the measurement of the square root of 0.7 times 1 minus 0.7 over our sample size of 83. This value of 0.05 should be pretty close to what you got for your simulation standard deviation. Up in the top of your, right under summary stats. Is that about what you got for your simulation? Should be. And then calculation of that standardized statistic, we take our statistic, 0.65, minus the null value of 0.7, and divide by the standard deviation, divided by the 0.05. And this gives us a standardized statistic of -1. When we click on normal approximation, down on our graph, we see that we get a p-value for that normal approximation of 0.3202. I want to take a few minutes to kind of talk about that empirical rule and using the empirical rule to find a p-value. All right, so this is going to answer questions 1A through C as well as we work through this. All right, so we have this distribution. So this is your 1C. And it says 68% of values are within 1 standard deviation of the mean. This is the empirical rule. 95% are within 2. And then 99.7% are within 3. The central limit theorem told us that our distribution would be centered at mu, or are centered at our true proportion of pi. What is the true proportion? What are we assuming for pi? 0.7. So that's going to be the center of our distribution down in 1C. It's also the answer to 1A. It's going to be centered at 0.7. And then it says that it will have a standard deviation of the square root of 0.7 times 1 minus 0.7 divided by our sample size, which is 0.05. Which is B. If we go ahead and fill this out, we're adding a standard deviation or subtracting 1 standard deviation from our null. So this becomes 0.7 plus 0.05, which is 0.75, and this becomes 0.7 minus 0.5, which is 0.65. And then we're just working out. So this one would be 0.8. I'm adding another standard deviation. This is 0.6. I'm subtracting a standard deviation. And the last one would be 0.85 and 0.55, because we're just subtracting or adding a standard deviation each time. Everybody kind of following what we did there? All right, so what we saw is our standardized statistic was -1. That means that my statistic, 0.65, is 1 standard deviation below the mean of 0.7. I'm doing a two-sided test, so I'm looking at the area less than -1 standard deviation and greater than 1 standard deviation from the null or from the mean. So I could find the p-value by taking 1 minus 0.68, which is 0.32. That would be this area in red. Does it look red to you guys? Yeah. This area here and this area here, okay? This is our p-value using the empirical rule. This will only work, we can only use the empirical rule if we have plus or minus 1 for our standardized statistic, plus or minus 2, which would be associated with 95%, and plus or minus 3. This p-value should be pretty close to what you saw when you clicked on normal approximation. It should also be pretty close to what we saw with the simulation methods. Okay, because our validity conditions are met, they should all be approximately the same. Questions on that? Okay, understanding the empirical rule with relationship to p-values if we have a standardized statistic of -1. Okay, the same kind of holds for the rest of this assignment as we're looking through the different probabilities. So using the probability calculator, where we set our mean to 0.7 and our standard deviation to 0.05. Did everybody get this far? Hopefully. We're looking at, the first one is looking at a sample proportion of 0.75 or larger. So we put that value in here. And we can see our probability is 0.1587. Notice this is at a standard deviation of 1, right? 1 standard deviations above, or a standardized statistic of 1. So that means that the p-value or the probability should be about 0.16, because this is just looking at greater than 0.75. So we would be looking at greater than 1 standard deviations, which would be half of that 0.32 we just talked about, which would give us 0.16 or 0.1587. It's an approximation using the empirical rule. For the rest of that exploration, you can just walk through these slides, or you're doing the same idea here. So that shows that probability. For the next question, we're looking at between. Notice that the 0.65 and the 0.75 are at 2 standard deviations away, which is illustrated here by our z value of -2 and 2. So we should have about 95% in between those values, or as we can see with our applet, 0.9545. This was part D. Part F, the value at the 25th percentile. This is saying I'm looking at a probability of 0.25. So I'm putting in 0.25 here, and you should get an x value of 0.666. This says at 0.66, at that value of 0.666, 25% of the values would be below that value. Notice that this one does not associate with a standardized statistic of plus or minus 1, 2, or 3. The last question on the supplement is looking at our p-value. For this, to find the p-value, you're putting in the value of your standardized statistic. So putting in that value of -1 for z, looking less than that value, and greater than the positive value, because we're doing a two-sided test. And this probability, now we're looking at the probability outside to find that p-value, would be 0.3173. which is pretty close to 0.32, which is what we found using the empirical rule, close to the 0.3202 that we saw using the normal approximation on the simulation. Questions on those using the probability calculator? All right, I want to introduce 3.2. We are actually going to start with just looking at the exploration. These are questions that we've already talked about, so it should be pretty quick to kind of walk through these. We're on page 177. I'll introduce the idea of confidence intervals in next class. Questions 1 through 5 in this exploration do need to be completed before you come back to class. Next class period. So looking at this study, it's looking at a random sample of 1,019 adult Americans, and they found that 80% agree with the statement that the United States has a unique character that makes it the greatest country in the world. What population are we measuring here? Question 1. What population are we measuring? Adult Americans, all American adults in December 2010. We do need to specify it's 2010 because some people weren't adults in 2010 by the legal definition of an adult. Our sample would just be the 1,019 American adults in December 2010. Sample size would be 1,019. Our actual sample is 1,019 American adults. We are out of time. Questions 1 through 5 in this exploration are due for class on Wednesday.